Okay, let's learn about density. Most of the rest of the next little while is going to be about density, practicing density, solving density problems. What is density? And then you have a fairly substantial assignment that you have to hand in, hopefully by the end of the day, if not, then tomorrow. It's probably the toughest thing that you're going to learn in this unit because it's a formula, it's math. Having said that, you guys were really successful with the calculations you had to do in physics and electricity. So I think that we'll be okay here. So let's start with what is density. Density is a measure of how much mass is contained in a unit of volume of a substance. It's essentially, it's how heavy it is, but it's how heavy it is per unit volume. For example, a ball, let's say a baseball size chunk of gold, has a much higher density than a baseball size chunk of styrofoam. I think that we could all agree on that. Most metals would be more dense than styrofoam. Now, that doesn't mean you can't have a chunk of styrofoam that's heavier than the gold. You would just need much, much more of it. If you had, let's say, a dump truck full of styrofoam, well, it would be heavier than a small chunk of gold, right? But gold is definitely the more dense of the two substances, or those two things, yeah. So a substance with larger density have more mass packed into a smaller area, or a smaller volume, a particular volume. Density is a characteristic physical property, which means that measuring density can help identify it. So characteristic physical property means that gold and silver have different densities. So if we can measure the densities, we'll be able to tell those two things apart, even if we couldn't see them and identify them by color and stuff like that. Actually, let's go back to that statement there. So I used gold and silver as an example, and I'm sure if I had a chunk of gold and a chunk of silver and I said which is which, you guys could figure it out without knowing the density. But most metals on the periodic table actually look very similar. They're usually gray, they're usually shiny. So you have to use other methods to determine, to identify them. And density is a way of doing that. So the formula is density equals mass divided by volume, or if you want to just use symbols, it's capital D for density, small m for mass, and you can use a small m or a small v or an uppercase V if you want for volume. Possible units for density are grams per milliliter, grams per centimeter cubed, or kilograms per meter cubed. Those aren't all the possibilities. You notice the common theme here is that you have a mass unit per a volume unit. Anytime you have that, you have density. And at least half of you liked using the triangle to solve some of your electricity problems. So there it is. Mass goes on top, density on the bottom, volume on the bottom. What that means is that if you want to solve for mass, you go density times volume. If you want to solve for volume, you go mass divided by density. And then, of course, the standard density, if you're solving for density, you go mass divided by volume. I'll help you with that as we do some of these examples. So let's move me down here and let's do them. I have 5 examples to walk through with you. I encourage you to stop this video and write down each and every one of them because they're all different. Now, I just kind of typed these up as I was thinking about it the other day, so there could be heavy typos in this. So it says a metal has a volume of 7 cubic centimeters and a mass of 20 grams. So just like with electricity, these are going to be marked out of 4. And the first mark is for identifying what you have. Volume is 7.0 cubic centimeters and mass is 20 grams. We are trying to find density. There, you get 1 out of 4 just for doing that. 2 out of 4 if you arrange the formula property. I'm going to draw that triangle up here again, density, mass, volume. So if we're finding density, it's mass divided by, or mass over volume. So I'm going to go density equals mass over volume. Over means divided by. So there's 2, 1 mark, 2 marks. And then I just got to sub in my values for the third mark, 20 grams divided by 7.0 centimeters cubed. And I should have been a little more prepared. Oh, there's my calculator, good. And I'm typing that in. I encourage you to pause it and try it yourself. 20 divided by 7 is 2 decimal, if I'm going to round to 2 digits, 9. 2.9 grams per centimeters cubed. So grams divided by centimeters cubed, make sure you use that for your units, grams per centimeter cubed. The formula tells you what the answer should be, and we put a circle around that. There's 3 out of 4, and there's 4 out of 4. Pause it if you need to write any of this down, and let's move on. What if we have to solve for volume? Okay, a liquid has a density of 1.5 grams per milliliter. Its mass is found to be 75 grams. Find the volume. So the density, and there's 2 clues here that tell me this is the density. It says density of, and also the units, grams per milliliter. 1.5 grams per milliliter. It says that the mass is found to be 75 grams. It says determine the volume. Let me draw that triangle over here where I have some space. Density, mass, volume. So volume says go mass divided by density, or mass over density. Volume equals mass divided by density. So that's 75 grams divided by 1.5 grams per milliliter equals, I go to my trusty calculator, 75 divided by 1.5, and it gives me 50. And what are they going to be? Centimeters cubed? No. Look at the volume unit in the equation. Milliliters is the answer. Circle it. Check mark, check mark, check mark, check mark, 4 out of 4. Oh yeah, and go back and pause that if you need to writing that down. I'm doing these pretty darn fast. Solving for mass, number 3, an object has a volume of 20 cubic centimeters and a density of 2.2 grams per centimeter cubed. Find its mass. So first thing I see is volume, 20 centimeters cubed. I see a density, 2.2 grams per centimeter. And I see a mass of, actually I don't see a mass, I see the word mass, and find its mass. Drawing my triangle again, density, mass, volume. If I'm solving for mass, I'm going density times volume. Mass equals density times volume. 2.2 grams per centimeter cubed times 20 cubic centimeters. Got to go back to my calculator here. 2.2 times 20 is 44. 44, and what's the unit going to be? Look for the mass unit in the density, grams. And done. Check mark, check mark, check mark, check mark. And we move on. Pause this video to write down what you need to write down. Try these on your cell phone calculators or whatever calculators you're using. All right, now this one is going to be very different. It's rectangular prisms. So it says a rectangular shaped solid has the dimensions 12 by 5 by 6. So this is one of those rectangular prisms which I always butcher when I try and draw, but that doesn't stop me from trying. And it has the length, width, and height of 12, 5, and 6. Its mass is 100. Find the density. Well, the easy thing to write is mass equals 100 grams. I'm going to write that down before I forget it. But the volume, well, I don't know what that is. I have to find the volume. And I'm going to do that. I'm going to do that over here on the right. I'm going to say volume of a rectangular prism is length times width times height. If you didn't know that formula before, well, I just gave it to you. That's the volume of a rectangular prism. So that's going to be 12 centimeters times 5 centimeters times 6 centimeters. And I'm going to get out my calculator because I can't do that in my head. And it gives me 360 cubic centimeters. Cubic centimeters because it's 3 times, there's centimeters multiplied by itself 3 times. Centimeters times centimeters times centimeters is cubed, centimeters cubed. So I go 360 centimeters cubed. It says find the density. So that was the only twist to it. And then the formula, of course, is density equals mass divided by volume. So I'm going to go density equals mass divided by volume. I'm going to go 100 grams divided by 360 cubic centimeters. It's going to be small. It's going to be 0.28 if I round it. It's actually 27 or 77 repeat. 0.28 grams per centimeter cubed. Just take the units, grams per centimeter cubed. That is the answer. Got this, got this, got this, got this. If I want to evaluate you on finding the volume and showing your work for it, I would mark it out of 5, but usually I don't. I just expect you to find that volume and I just mark it out of 4. All right, on to irregular solids. Is this the last one? It might be the last one. It says an irregular solid has a mass of 33 grams. I'm going to stop right there and say mass equals 33 grams. It's placed into a graduated cylinder with 20 milliliters of liquid in it. When submerged, the liquid went up to 32 milliliters. Find the density of the solid. So what I mean by submerged and the liquid level went up. So before we put this irregular solid in, there was 20 milliliters of liquid. Then we put this chunk of irregular solid in there and the liquid level increased to 30 milliliters, or 32 milliliters, I should say. Math would have been easier if I'd left it at 30, but it says 32, so we better do 32. So what was the volume of the irregular solid? Well, the answer is it's the difference. If it was 20 milliliters before you dropped the chunk of solid in, and the liquid increased to 32 milliliters after you dropped it in, then the volume of that solid was 12 milliliters. I did that by going 32 minus 20. So I'm going to go over here. I'm going to write volume equals 12 milliliters. I'm going to write density equals question mark because that's what it wants us to find. I'm going to look at that formula again, which is density equals mass divided by volume. So I'm going to write that here, mass divided by volume. And that's going to be equal to 33 grams divided by 12 milliliters equals, I go 33 divided by 12, 2.75. What are the units? Grams divided by milliliters is grams per milliliter. Circle it. 1, 2, 3, 4 things done. That's how you measure the volume of an irregular solid, because you can't measure its length, its width, and its height if it's just a chunk. I have anything else here? No, I don't. So I'm going to exit out of this. I strongly advise you to go back if you didn't write some of this down and go get down the examples. Your last evaluation in chemistry will have density problems on it. So let's see what you are up against next. So for the next little bit, I just want you to go into the book. And it doesn't, let me see, did I say to read it? No, I didn't say you have to read the section because I did a pretty thorough job of explaining to you how to calculate density. Now, if you didn't like my example, then there are more density examples in here. If you think my writing's terrible, my explanations are no good, there are decent textbook explanations in here, or at least one good example that I just saw there. But what I actually want you to do is the numbers, let's go back to it, 4, 5, 6, and 7 on page 198. Now, I have copied and pasted those questions into this document. But see here, I say, insert a picture of your solutions. Let me just zoom in a little bit to like 150, let's say. It says, insert a picture of your solutions in the spaces. So, because I don't think that you can type the formula and get the units all right and get the superscripts. If you think you can handle typing them in, that's great. But keep in mind, these would be out of 4 marks each. Okay? So make sure you do all of the steps. Get in that great habit of doing all of those steps. When it says refer to table 193 or table 1 on page 193, that's where you have to go into that section. And I knew I had a reason for posting that in there. So the table on page 193 is in here. And it is right there, table 1 on page 193. And it lists densities of some common metals. So work on those 4 questions. That's all you have to do for this particular block. And I'll either collect those from you or I'll take them up in the next block, okay? So make sure you insert pictures of your solutions unless you think you can work your way around writing or typing right into that document, all right? All right, I'll stay on Google Meet in case you guys have questions. Good luck.